Good afternoon. My name is Cole Williams, and I'll be talking about pervious concrete in this presentation. Pervious concrete is a substitution to traditional concrete in the sense that it allows water transfer through the material to the subterraneous layer that is under the material of concrete. This has many positive benefits of using pervious concrete over traditional concrete. It reduces flash flooding, it helps the environment, cleans rivers. You don't have to have curb and gutter, because the water will be retained under the soil. You get rid of retention ponds. There's just many environmental and economic benefits to the implementation of pervious concrete, and we will explore some of those in this presentation. Pervious concrete is it's a matrix of cement paste and aggregates, and the type of aggregates is very important in the implementation of the pervious concrete. And that concrete really retains pretty similar compressive strength and tensile strength to traditional concrete. Now you will see a reduction in that mechanical properties because there's a higher percentage of porosity inside the material. The aggregates are usually spaced 6 to 12 millimeters apart, which provides a nice void between that and the cement paste to allow water to transfer through it. And traditional concrete, the aggregates are usually 2 to 4 millimeters apart, and the aggregates are a lot smaller than they are in pervious concrete, and this obviously provides less of a path for water to travel through. This raises the compressive strength and the tensile strength of traditional concrete, but you see some negative effects of traditional concrete like water buildup, flash flooding, the urban heat island effect, because this material is a lot more compacted. So there's pros and cons to the pervious concrete, but in certain implementations of pervious concrete, it can be a great substitution to traditional concrete. So the traditional concrete is great for bridges and large structures and roadways that have high density of traffic, because it suffices more for compressive strength and tensile strength, and the aggregates are closer together, and that provides obviously less water to travel through it. So you'll see water build up on traditional concrete that you're not going to see on pervious concrete. Pervious concrete, however, obviously has a lot higher porosity, which is the main effect of implementing pervious concrete in your project. But you will see a reduction in tensile strength and compressive strength, and you have to weigh these pros and cons of implementing pervious concrete compared to traditional concrete. Pervious concrete can be great for things like sidewalks and parking lots because it reduces the curb and gutter effect, or you don't have to have catch basins and drop inlets, and you won't see nearly as much flash flooding in urban centers or roadways. When installing pervious concrete, there's a few things to keep in mind that a contractor and engineer would work on before the project was actually underway. The subterraneous layer needs to be thicker than when utilizing traditional concrete, because the water, when it runs through the pervious concrete, will obviously eventually erode the subterraneous layer that you have under the concrete. So you'd need 2 to 4 more inches of gravel usually to be laid under the pervious concrete, and this is one of the things that somebody needs to keep in mind when they're wondering that we need to implement pervious concrete into our project. But when you say you got to lay 2 to 4 more inches of gravel, that cost up front is a little bit more expensive. But when you think about the cost of installing curb and gutter and catch basins and drop inlets, and you think about the cost of flash flooding in your area, you really start to weigh these out, and pervious concrete looks very enticing to use in your project. The contractor that you employ as an engineer should be well versed in pervious concrete, because the curing and the laying of pervious concrete tends to vary a little bit from traditional concrete, and you would probably want more of a expertise knowledge from the contractor, so we don't have cracking or unraveling showing up from a contractor who hasn't laid pervious concrete before. The freeze-thaw cycle is a huge issue with pervious concrete. It's been well documented and well studied, and in my paper and in this presentation, I took it very seriously, because in colder climates, when pervious concrete freezes, it tends to crack and unravel at a much higher pace than non-pervious concrete. To fix this, the pervious concrete should be compacted a little bit with a little bit less voids, maybe 12 to 18% porosity instead of 15 to 25% porosity, which is the normal range of porosity in pervious concrete. This will allow the water to seep through, and when the water freezes, there will be less space for when the water thaws out inside the concrete to crack the material and to unravel the material, because the compressive strength, the tensile strength, the toughness, and the resistance to cracking will be higher when you have aggregates that have less space in between them and smaller aggregates at all. So this will improve the strength of the material while still allowing 12 to 18% porosity. So it will fit your needs while preventing the harsh freeze-thaw cycle that some see when they install pervious concrete in a cold climate at 25% porosity, because you're going to have that water build up in the pavement and it immediately freezes, and the next morning you're going to see it thaw out, and when it thaws out, it's going to expand, crack the material, or unravel the material. Then you're kind of clogging in the pervious concrete, and at that point, the idea of using pervious concrete will be negated, because the material will be clogged, and it'll be a waste of the project. Lightweight aggregates are a huge deal when considering what kind of pervious concrete you want to employ in your project. There's a few that I studied in particular: diatomite aggregate, the recycled aggregate, and the pumice aggregate. These different aggregates provide less dense means of still having pervious concrete, so they provide good compressive strength, tensile strength, and toughness while allowing for a less dense material. So the lightweight aggregates are great for like structural walls, because they suffice for load bearing, but they also are less dense. So on second and third and fourth stories of buildings, you have less dense structural walls, but they're also comparable to regular concrete walls that are holding up the same load. So this is an excellent substitute for regular concrete structural walls. You can see in this chart that it was studied by a source that I studied pretty in depth, and the diatomite aggregate tended to show better compressive strength over 28 days, especially at 25% cement to matrix ratio, which is the cement paste inside, which will close up. So the higher the percentage of the cement paste, the lower percentage of porosity. So at 25, you're going to see a higher compressive strength, but you are going to see a lower porosity percentage there. But the recycled aggregates and the pumice aggregates are actually pretty comparable in the compressive strength. So it depends on what you are wanting to do with your project. So if you're wanting to build a road, say, you would probably go with diatomite aggregate, because you want to avoid unraveling and cracking. But if you don't need that compressive strength, recycled aggregate can be great for structural walls and sidewalks and parking lots, because you're helping the environment. The aggregates are a lot cheaper, which the concrete would be a lot cheaper than diatomite concrete, and diatomite's a little bit more expensive. So you got to weigh the pros and cons of each, and recycled aggregate can be a great substitution for even a regular aggregate and pervious concrete, and also a great substitution for traditional concrete. Pervious concrete can be used as roads on less dense traffic areas. So when you have more of a dense traffic area, you wouldn't tend to use pervious concrete, because you can see a lot of unraveling and cracking. But on rural roads and rural townships, pervious concrete can be an excellent way to put in roads without having to put in curb and gutter, catch basins, and drop inlets. And obviously catch basins, drop inlets, and curb and gutter will dip into the coffers of the small town. And small towns don't exactly have the funds it takes to supply the curb and gutter and adequate drop inlets to prevent flash flooding. So pervious concrete would be an excellent way to put in roadways without paying a hefty price tag for a rural township. Also, you won't have to buy retention ponds, which will allow farmers in rural towns to have more land to farm, which will help the socioeconomic status of that town. and the town can use the funds that they would have used for drop inlets and catch basins and curb and gutter to focus on more important things, obviously, like schools, feeding the town, and whatever you need in disasters. You would have more money left over after using pervious concrete and not having to use catch basins and curb and gutter in each project. The porosity percentage is very important in pervious concrete. At 25% porosity, you're going to get the most water transfer, which is good for some projects like a sidewalk or a parking lot. But you're going to have less compressive strength, you're going to have less tensile strength, and that can be an issue. So on a rural road, you would probably have 15% porosity. So you're going to have less of a water transfer, but you're still going to have adequate water transfer, and you're going to have more compressive strength. You're going to not see as much unraveling. And when a contractor is deciding and an engineer is deciding what he wants to do with his project, they really need to meet and decide what intention they want to do, or what intention they want the pervious concrete to serve, because from that you're going to select your porosity percentage from there. So if you want 15% porosity and you want good water transfer but better compressive strength, you're going to go with 15. But if you want very good water porosity percentage, you're probably going to go with 25 if you can afford to not have as much compressive strength. Recyclable aggregates, we've already covered it in the presentation earlier, is a great way to help the environment. And it's also a great way to reduce cost on your project. And it really gives a contractor and engineer a natural way, or a natural, I guess coercion's a bad word, but a natural reason to help the environment while also helping them on their project. And that tends to help everybody. When you don't have to make a contractor or an engineer do something and they'll try to subvert the system, when it helps them and also helps the environment, that's the best situation you can have. And when you use steel aggregates or steel slag from the junkyard, it provides great tensile strength, great compressive strength, it provides good porosity, and it also obviously helps the environment because you don't have steel laying around in a landfill waiting for it to deteriorate over 50 years. So it's obviously great for both parties, the contractor and the environment and the society in general. The environmental benefits, I mean, you could go on forever talking about the environmental benefits of pervious concrete. Honestly, that's, to me, the most important part of pervious concrete. You have less trash in the rivers, which is a big one to me because we have the Neuse River near us, and you go to the Neuse River, there's a lot of trash floating around, the water's dirty, and that's not how the world is meant to be. And it's from water running off into our rivers with trash in it. And you can see on the picture on the right, it's just trash piled up in a catch basin. With pervious concrete, what you get is water into the subterraneous level, and this is obviously going to disintegrate into the soil, and you're going to have water in the soil to help plants and trees and other greenery build up, which is just a win-win for everybody. You're going to reduce flash flooding, which is excellent, and you're going to have less of a urban heat island effect, which is another great way to reduce our carbon footprint, because pervious concrete has been seen to hold less energy, and overnight they won't release that. Pervious concrete won't release as much heat as traditional concrete into a city, making the heat effect feel greater, and that's going to reduce our carbon footprint overall. In conclusion, pervious concrete, in my mind, is just an excellent choice for a substitute for traditional concrete in certain situations. So I wouldn't use pervious concrete for an urban roadway because you're going to see some unraveling, you're going to see some cracking. But I would definitely use pervious concrete for rural roadways. That's a great way to help the town while also helping the environment. And when you won't see catch basins and gutters and curbs everywhere, and it's going to help economically and environmentally. The aggregates of pervious concrete definitely can be recycled, and you can use steel slag and recycled polymer, and this is just another great way to help the environment while also reducing the cost of projects, which is a win-win for both the contractors and engineers and society. Lightweight aggregates are great for structural buildings and structural walls, and in my opinion, the aggregate should be 6 to 12 millimeters in size to produce the best results. Thank you.